Hi, today we're going to talk about an upgrade of an existing script. So in the past, I've demonstrated this view arrange tool. What it does is that it reads the number of views on sheet and it tries to place them into grid centers, like this. I will put the link to the video view arrange down in the descriptions, so feel free to check that one out. But today we're going to talk about view planning. So the limitation about view arrange is that even though it runs very fast, it reads the number of views and always try to place them into fixed grid. So when you encounter this, where you views are different in sizes, you see that they go beyond the boundaries and they're just going beyond their grid slots because they try to place the views in the center. Instead, we can take a look at view planning. I'm using this in Revit 2018, so you get this edit input button here. Now if I start to run, see this one, it tries to place everything next to one another without overlapping between views and without going beyond the boundary. I can use the gap to control the relative gaps between different views. So let's increase that to 2. And we already get some good results. We could try 3. And there are views that doesn't get placed into the 3 gap arrange. Or we can just use the grid. When we use a 3x3 grid, we know that doesn't work, but we know that the not working views will get thrown out of the boundary, and it tells us to change the grids. Let's try a 4x3 grid. To run, still something that I can put in, but let's see that in the 4x3 grids, we have number 1 view is occupying 2 slots and placed in the center of these 2 slots. Number 2 view, K, is occupying 2 slots in a vertical way and placed in the center. And then there's 3, 4. After placing 4, there won't be any place for 5. So 5 gets thrown out. And then 6, 7, 8. And then lastly, there won't be any place for 9. So 4x3 not working. Let's try 4x4 then. Right. Now everything gets placed in. If we look at the 4x4, we know that again, 1 is occupying 2 slots, 2 is occupying 2 slots, 3, 4, and then 5. 5 won't fit there, 5 won't fit there, so 5 fit there, occupying 4 slots. Then 6, 7, 8, and lastly 9. So we can just use this if this is the ideal orientation, or we can start shuffling things around by changing the detail numbers. So it always try to place the views according to the detail numbers. So if I change 9 to 2.5, it will go to there and shuffle everything back by 1 view. So run. See that R get moved on top next to 2, and everything just shuffle back. So if we think the size of the view are more important, we'll go ahead and change n to a detail number 0, and it will go placed there, and 1 will push somewhere here, and then there will be 2 and 3. So for 1, see something like this. Or we can change J to number 4.5 and run. So something like this. J get put over here and the smaller views just lying afterwards. This is a more visually balanced orientation. And we can even try change grid to 5x4. Now in a 5x4 grid, you get smaller views filled over there, and you have open space for other views to come. I kind of like the 4x4 more. So this is a more filled view, filled sheet. And obviously we can also always hide the grid to print. Everything will be good. Or turn on the grid and work on the arrange of views until we find the ideal solution. The view planning is the same as the previous view arrange. It will move only the views, but not the legend nor the schedule. So views get rearranged, but not the schedule or the legend. And it uses this grid as the boundaries, so I can just move that. So we have space set for the legend or schedule. Imagine this is a long schedule. If I go run, everything will be placed into the centers, nicely arranged, like that. But to think of it, the application of viewer planning is beyond just placing views on sheet. So it tries to place a number of things according to a boundary without one overlapping another. It can be used, imagine these are rooms and this is your site. This can be a site planning too. If these are model element and that's your room, it can be a room planning too. Really, it has other applications beyond just placing views. So, for example, let's imagine this is a space planning, and again we're using 3x3 grid. Try to run that. We see that something doesn't get fit in. We will just increase the number of grid, study the different placing options, and when we get one of the results, we can study the adjacency relationships between different rooms, now they are rooms, and study whether that will fit in our criteria, by our criteria, or try to rearrange views by changing the detail number. So if I want to swap these, let's see, so change that to 4.5. And I get a different layout. So the application of view planning is beyond just placing views, can be a space planning study too. And analyzing, it can iterate different sequencings to study what is the most ideal layout and support the design process. Okay, that'll be all for today. Thank you. See you next time.